Hey guys, this is the last part of the fundamentals, and we've covered most of what I wanted to get through now, the main techniques used. But this last video, well, I'll try and explain sort of why I use those techniques, as well as just showing you how to do them. So we'll get started on the first piece, which is meant to be similar to just something you might find while doing a car. You know, it's got symmetry on it, and you want to figure out how to get rid of lumps or any possible pinching or problems that you see. But it's relatively simple, but it's just to explain, and we'll get started on that. So it's just like every other piece so far, just a plane. You can add a symmetry on it straight away. Oops. You can move the symmetry modifier at any point. If you have slice along a weld seam on, it'll just cut and match up, but at a later point. So if you want to center the pivot on the center of the symmetry, move it wherever and go into the hierarchy tab, and then click effect pivot only and centered object, and that'll just line it up to the center. Then when you've got your vertices not aligned anymore, you can just copy them. You can find where the object is in space, grab those vertices and copy and paste that value so it's centered. It's really important to keep everything along the axis when you're modeling, so nothing's not welding or might be pinching or just any problems. You can just snap it back to where the value you've had originally. So just start off, we'll hide that piece. Just dragging down at this point, just add a turbo smooth to it. Okay, you can see that it's smoothing a bit weirdly. If you ever get that, that's probably because you've got your stack not set up correctly. So whenever you add a modifier like symmetry, always make sure you're smoothing on top of it, and then you'll fix that seam down the center. So straight from there, we need to connect a couple of pieces, and just using the cut tool, straight out cut it along and delete that piece. I'm just going to sort of extrude out like a wing or something like that. So when you've got tilde set, you can just really quickly see where you're at with the smooth version. So like I'll always be constantly swapping back and forth, and you'll notice that not everything I do is really linear. It's always just mucking around, seeing what type of shapes you can get. So to smooth this, just like usual, we'll cut in, connect through it, and you can see because I haven't actually modified that angle there, it's smoothing nice, there's no pinching. But if you're working from blueprints and you go from above and you see that this curve needs to be pulled out more and that's not correct, and you pull it out, then you go back from the side view and you can see it's starting to create a little bit of lumpiness. So always looking for, if you're trying to figure out where the problems are in your mesh, just put on like a very high specular material and look at glancing angles. So you'll see that that's actually, if you look at it from back here, it looks cool, but you go from side on, you can see it's not that good. So to fix that, you got to start doing a bit of hand tweaking, and that's partially just trying to average out that curve. Another thing to note is if you're matching up a curve, like as an example, I'll just draw one along here. If you're trying to match to this curve, Let's just say that's our curve. Doesn't need to be anything special. I've seen people try and do it. It confuses me a bit. Like they'll line it up from above, and it'll all be matching correctly. So they'll find it. They'll find where the line is, move it left and right, and match it up. Then they'll go to the side view and see that it's not lining up. And those vertices that they've just moved to the right to line up, they'll move forward. So you'll move it up, and then you look at it from above, and it's not even lining up to that curve anymore. So they push it back. And if you're ever trying to match from blueprints, just try and keep it as like linear as you can. So if you've got a curve, match it from one angle. So moving this on the X and Y, just keep it snapped on the X. Then when you go from above, you've already moved it forward and back. So the only place you can move it to lock it into place is left and right. And that way you're not going to stuff up this view. And you can keep modeling, and it ends up making cars and everything like that a lot quicker if you're going from blueprints. So just try and keep things, following along on one axis and then on another axis, not, in 3 axis from all different views. You'll be sitting there tweaking for hours. So now we've just got to add a little bit of a curve to the side. And I'm not looking at this curve here. I'm looking at the inside isoligned curve. This is just for having the cage is just for sub-D modeling, just seeing where you're at with the low poly. But if you're doing any high poly stuff that ends up having to be smoothed, always try and focus on the smooth version, because that's what you're rendering. So if I'm modeling and I'm moving something from this side of view, I'm not actually looking at this side, I'm looking at the opposite side, because that's where there's no interruptions with the cage over the top, and you can just see sort of where the problems are happening. So you can see that's not exactly smooth, so we can make that a little bit smoother. This will probably be a bit too far up. And doing it this way also, it keeps you from adding too much geometry. If you keep playing around with what you've got, you'll eventually get to where you need. I mean, sometimes you need to add more geometry, but if you keep it as low as possible. So that error that was just there, it looks a bit warped in. Move that out just a little bit, it fixes it. Now I could have just gone and added in a whole nother loop and kept trying to tweak it. But if you keep adding before you've actually got to where you want, you're going to end up having to remove stuff anyway. So only add stuff, only add edge loops and things like that when you need them. And just eyeball. You're not always, like I've just connected that, and that's damaged that loop I had going along here that was nice and smooth. So if I remove it, you'll see that this curve here becomes a little bit smoother, and it looks natural again. But because I added it, it's pinched it off. So you're just gonna have to manually fix that type of stuff as you go. So it's just a lot of observing. You can see that it's starting to look nice and smooth. Another smooth on it even if you want. Now next step would just be adding a bit of thickness to it. Just dragging down. Really quick to just weld stuff back up, so you can always do that. Same from the back. Now if you ever get into a situation like this and you need a hard edge along here, you can always chamfer it, but you'll see it's not the best way to go, because you end up with a end gone, which can cause pinching. So always, like I've said in the last videos, just try and keep it If you're ever trying to harden up an edge, just connect along and slide. See, there's something going on here. Just need to connect it. Some problems up the back here. And every so often with your model, just, you know, take a step back and, you know, look at it from afar, because there'll be stuff you've missed. And, you know, if you're ever trying to post to a forum looking for stuff and it's like something seems wrong to you, just take a look before you post it and, you know, sort of go over like you're reviewing it for a boss or something like that. And we don't need to cap the underside, because usually with a car it's just all flat. So that's looking nice and smooth, and yeah, that's the first piece. And it's just, you know, it's not like technically hard to do, but it's just a good demonstration of showing you sort of how to go about modeling using the wrong side. So you can always look for a problem on this side, you know, go back over to the right side, find it, and then only model on this side. So the gizmo will be over here, but you're not actually looking at that side, you're looking at this, the correct side. So that's the point of this piece. Oh, you can always, forgot to harden it up, but yeah, you can see. That's another good way to see where things are going. So this next piece is similar, just same technique. But a lot of learning the model is repetition, so it's good to be doing this stuff a lot. You know, I'm still trying to figure out ways to do this stuff better. So center it again. You can see with planes, you'd probably assume that was done with a box or something like that. It's all done from planes, and you know, you can really quickly block out primitive shapes anyway with planes. So I don't see the point of using box modeling for anything really. I mean, cylinders, it's another problem because you've got to keep it, you know, all mathematically correct and stuff. But so we'll just hide that piece. Whoops. So the turbo smooth's on the wrong side. Just assign that blend. Okay, so let's just say you've got a flat surface and you've connected through it, and you need this to be rounded off just slightly. So you connect that piece and then you lift it up, and you know, it looks cool, but you can see it's creating a little bit of wobbliness. So you need to manually go in and fix all these pieces that are, all these rows that aren't matching up with that curve. And even though it's, you know, a really small adjustment, it still makes a big difference. So you can see the difference from there is no pinching, it's a flat surface, to before anything was moved. You can see how it looks. It looks almost like it's, you know, concaving in. Next we need to just connect straight through, as long as you fix it up from the side. And just like the original, you've connected, and that's going to damage that curve, so you need to move it up. And this is just that little inset piece. So as soon as I've cut it, you can see it's messing up the geometry. So I need to do some tweaking to it. Just chamfer it off. It's not exactly straight. Now, don't be afraid to do extreme movements. I mean, you'll see that it's fixed up the curve on this angle, but then you look at it from side on and it's a piece of crap, so just need to manually tweak it. And that's where you get the whole poly pushing idea from. So with the other videos, I've tried to minimize this because it's not always pretty, just manually going in and tweaking vertices, but it's when you get into a more complex mesh than the stuff I've gone into before, you gotta do it, you know, there's no going around it. You can't just have it perfect first time. So once again, I'm not looking at this side, I'm looking at the opposite side. I'm just trying to look at the hot spots and see what they're doing, where the light's reflecting off. So another problem is that now that I've connected along here, that I've just noticed that it looks flat again, and that's because before this stuff was in, these faces here were, you know, the same width, but now there's, you know, 4 extra lines there defining that curve, so they need to be moved down. Don't need to snap them or anything, you can just move them straight over, and you can see the effect that that has. It's quite dramatic. Yep, there's a little bit of a pinch in the middle there. And now it's gone. So you see these end bits get a little bit finicky, trying to fix them up. Just trying to observe it from all different angles. you shouldn't be afraid to try and just weld different places, see what happens. It might end up looking something that you don't think would look good on the mesh, might end up looking perfect for what you want, which is what this next piece will show you. But yeah, that's that piece out of the way. Just it's not so much about the piece itself, more just about showing sort of how to go about doing this like curvy surface modeling and how to get rid of any errors you see. So not actually, when you're focusing on this side, you're focusing on the topology and the wireframe, but on this side you're focusing on the end result, and that's how you see it when it's rendered. So this is the most important side, because however the wireframe is, it'll end up looking worse or better on that side. So that's the final result, and that's what you have to pay most attention to, and this is more just the tweaking side. So just try and look at a model as two different processes. Okay, so this next piece I was asked how to do. We've done more like circular insets onto other circular insets. This one will go into doing more of a hard-edged approach. Similar to what you see. Some people would just go about beveling that sort of detail, just because it ends up with pinches. But I'll show you how to do it with polygons. Just start off with the cylinder. Get rid of the height segments. And this one has 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 24 sides. Yep. So we'll get rid of that. Apply the same material. And just scale this in. That's the first thing you want to do. You can't add, once you've got this angle here, you can't go in and add more of this hard edge stuff, because this is, you'll see that like you're scaling this and it's all symmetrical on all sides, so not actually affecting anything. So make sure you've planned it out, the angle you want on the cylinder, and once you've found that, lock it off. Just delete the side. Just delete the top and bottom. Now next thing is to put it on the 0 axis. And you can just go and add those hard edges if you want. So next is the rectangle part. Okay, so there's your hard edge. Now make sure that's all centered to 0. So next is to just go in and cut along there. Same as we've done with a circle, but this time it'll be with a rectangle. And the snap doesn't seem to be working. Oh, there we go. Okay, so you've got your hard edge in. Now just terminate the sides. And similar, just delete the inset part. And we'll see how that looks smoothed. Maybe it'll have some problems where I've connected. Okay, so no actual cutting errors, but now you've got to harden off those edges. So you want to pull this part down. In fact, do those together so they're the same. And when I'm swapping to X-ray mode all the time, which is Alt-X, that's just because I don't want to select anything behind. Now if I don't have anything on, I can select them just as easily, but then without noticing I've selected vertices up the back here. So that's why I use X-ray mode all the time. Now we'll need to harden it off on the top. See, it's looking okay, no actual problems yet. There's a little bit of pinching going on where there's edges closer. The edge is closer here than it is from here to there, but we'll fix that in a second. So next is cutting in, connecting along the edge here, and this will require leaving a couple of end-ons, just because if you terminate them you're creating edges for it to pinch against. So set it to 2 and slide it out, and just delete the inside ones. Okay, so that's the first part. The next part will be connecting along this angle. And that's creating pinching. Okay, so you've got the edge here and it looks like it's creating a little bit of a weird pinch around the side, so to fix that we'll need to connect a little ring around the outside face and slide that in. And now it's creating just this weird little pinch. So to get rid of that, okay, so once you've cut that square inset, you'll need to see how it looks and start hardening off some edges. And the first one will be chamfering this here, which will give you the hard edge along the top rim. The second will be adding a little bit of hardness to the sides. You can see there's still no problems. I mean, of course it's not fully rounded, fully hard edged. So the final part is connecting up these pieces here. And you can just set your connector to and remove the inside edges it creates. Whoops, this last one I accidentally connected too far down. And that is how to get the hard edge. I guess you could try and see how it looks if you want to make it even harder in there. And that works also. So yeah. You can do that, I guess, for any shape, just some will require a bit more tweaking than others. Okay, this next one is, I've showed you how to do cylinders and all that type of detail, but this next part, will just be going into adding a cylinder onto another cylinder. So to do that, you need an 8-sided cylinder and a 12-sided cylinder. The more size you have to the cylinder, the easier it gets to do it. Like, the easier it gets to fix the errors that it creates, but 8 and 12 is the ideal amount for that. So we'll center these. And give it 12 sides. And just delete the top and bottom. And give it an even amount of edges going up so it creates square surfaces. So that'll be good. Next thing we need to do is add the 8-sided cylinder to the side. Make sure it's zeroed off. And to get the right height here, we'll need to figure out where those vertices are on the z-axis. So just copy paste, they're at 32.192. And you can just copy that in. Now it's all centered and 8-sided. And now we just do what we've always done, which is cut. Now, you'd think that'd be as simple as it is, but there's a little bit more to it than that. So grab the border, extrude that a little bit, and now you'll see that it is causing some weird stretching and pinching on the sides here, which I'll show you with this material applied. Yeah, that's not what we want. So to fix that, it's a little tweak. You're just grabbing these vertices here, the side, turning on edge snap, and scaling them out a little bit until they're rounded. And that will get rid of that error. You can always harden it if you want. Might even need to just move in these vertices along the side. You can see that it's sort of coming out. Just move them in. Whoops, turn off edge snap. Just move them in until it's more flat. And that's creating a clean edge. Looks like it's a little indented on the side there. Should probably pull those out. And then you just flatten off these. So that's that piece done. So just remember to bring out the side edges, just so it smooths off better. And now this one maybe it's a little bit sort of not exactly to the point, but it's just like a minigun barrel, which I did in my latest competition entry, and I'll just show you how to do that. First, just got to remember how many sides this had. 1, 2, 3, 4, 5, 6, 7, 8. 32 sides. And it needs to have enough so that it's going square. Now we're just going to get rid of everything we don't need to start it off. So we're left with just one segment. Zero that. Oops. Other boolean. Now we're going to get rid of everything but 8 of the pieces. So make sure the 2 you leave to cut the circle on are the ones facing flat, and then an extra 2. So this is where we had our circle, interpolation set to 1, and just never snap. So that's not creating any problems. So there's one hole done. Now we're just going to do a whole lot of stitching and rounding off. So we'll make sure it's set to 1 degree. And we'll need to do it 8 times, I think. 7 times. So now you've got one part of the circle done. And just attach all those up. Going to extrude up once. Set it to 0.5 on the angle snap. Ah. And then it'll all be nice and aligned. So attach those and just do a global weld on it. If you ever need to select like 2 borders and weld them up, just select the borders and convert it to a vertice selection, and then you're not selecting any of the crap that you don't need to weld. So see if that's smoothed. It's working. And now it's just, you know, going up enough times that you're happy. So grabbing the border, converting to vertice, and welding. And that is how to do a minigun barrel. So there's no pinching or anything like that. and all the topologies as clean as it can be. So we've got one last piece, which is something like a grate, or doing a circle with a bit more length to it to create an oval. So this one's pretty simple. Sorry we didn't end up with anything a bit more advanced, which is just trying to stay away from that with this series. Same as before, we'll just stick to one piece, and then we'll just duplicate it later. So we'll just quickly bodge up just an oval shape. To do that, it doesn't actually need to be connected at all. You can just turn on snap, create the outside pieces, and move that into the center. Group it. Just going to find out where that vertex is. And now we can just begin cutting. Oops, that last one didn't connect. Just do that in perspective. Now when I'm trying to shift drag in like I usually would with a cylinder, but because it's more long, it has more length than it is wide, it'll stretch it weirdly, so you just need to extrude it in and then do a little like manual scale on it before you go in. You'll have to always do that. Now just center it. Now if you need these to match straight away, like if you're doing a car tire or something and you're doing one segment, just snap the pivot. You can do it just like you would a vertex. You'll have to turn on a setting with the snap options as use axis center as the starting snap point. Otherwise it'll just snap where you've got your cursor, which it seems to be doing here for some reason. Weird. That's what you'd call a bit of a bug. There we go. And then you can, whoops, get out of that and snap it. It's doing it again. Yep, there we go. And now it's, all. Whereas before when I was doing the minigun, I didn't snap it. I didn't snap the pivot to the vertex, just because it didn't need to be perfect. This one I'll do it a little bit different. Just show you how you can snap stuff. Well, yeah, that's the end of the series, guys. Thanks heaps for sticking around and watching them. I hope you guys got something out of them. But just try and keep practicing them and try to think of a model, not so much as a piece as you're going along, like as something as an end result. Just try and look at it as what it is, which is just a whole bunch of curves connected to each other, through edges and polygons and whatnot. And it'll start to dawn on you that it's not actually that complex to do those types of shapes, because you'll be looking at it at such a small level. It'll be a lot easier to understand what you're doing. So yeah, thanks heaps. My name's Grant Warwick.